Okay, so we are going to switch from using standard form into what's called factored form. So far, all we've done is this, which is standard form. And we saw in the last lesson that there are pros and there are some cons to this. Okay, so we can find the y-intercept if the equation's in standard form. All it is this c value. Or the number, the term without an x with it. All those mean the same thing. We can also figure out what the direction of opening is. So it's 50-50, right? Up or down. So you look at this number here in front of the x, or if it's just 1, that's fine too. Is it positive or is it negative? Yes. Okay, so the other form we're going to use is called factored form. S, sorry. Hi. Mm. Yep. Okay, so A we've already seen, X we've already seen, Y we've already seen. So R and S are numbers, and they could be whole numbers, they could be decimals, they could be fractions, but in grade 10, they're either going to be positive or negative whole numbers, okay? So when you have a quadratic relation in factored form, then you can still tell, because you still have an a value, you can still tell what the direction of opening is, but there are other items that we can get from this factored form as well, okay? So we can still use the direction of opening. They're still fine. But when you have the factored form, one of the most useful things you can get from this form is the roots or the x-intercepts, because then we can use that to find the vertex. So right now, all you'll have to do is look at the RNS values. Next chapter, chapter 4, that's where we're going to do how do we get an equation from standard form to factored form. That's what chapter 4 is. Once you have the zeros and the roots, so this is what we did in the last section, then you can find the vertex. So remember we found the halfway point. So R for the x value. Take the two values and find the middle, right? Divide by 2. Then sub the x in to find y. Once you have the vertex, then you can do the axis of symmetry. And I'm even going to sneak in optimal value. You can do the optimal value, right, as well. So using similar terms over and over and over again. What's the vertex? How does it open? What's the axis of symmetry? Is it a max or min? What's the optimal value? What are the zeros or the roots or the x-intercept? Okay, so we're basically going to do two examples, given only the equation, and then what happens if you're given a parabola. Okay, so here, now the equation doesn't have an x squared term. 3.4, what we're going to do next is what happens when you have two binomials like this. How can you make it into standard form, which is such an important skill, okay? But for now, we're just going to look at, we can do some simple algebra here. We don't have to expand it. Okay, we can leave the equation as is. So the one thing we are trying to find with the zeros are where the parabola crosses the x-axis. So what's the y value when you cross the x-axis? What's y equals? Pardon? I think I heard something say it. No, it doesn't matter. Anytime. No matter what kind of thing you have, if you're crossing the x-axis and you're looking for this, what's y? 0. Okay, so the zeros, the x-intercepts, we're looking for when y is 0. When you multiply something by 0, what do you get? 0. A million times 0, 0. X squared minus 3x plus 3 times 10 times 0, 0. Okay, so no matter what, if you multiply if one of your terms in the trinomial, binomial, polynomial, whatever, is 0 and you're multiplying, you're going to get 0. So we have, usually in factored form, we have two sets of brackets. So here, if this number turns out to be 0, that would make this 0, no matter what this is. If it's a million, a billion, a zillion, whatever. Same thing here. Whatever's inside these brackets, because it's multiplying, whatever it is, whatever x is, to make 0 will make the y value 0. So you can either figure this out using algebra, but maybe you'll be able to see it as well. So here we have two possibilities. So if x minus 4 is 0, then y will be 0. If x plus 2 is 0, then y will be 0. Okay, so we have two roots, which makes sense. Many parabolas have two roots. If what's inside this bracket is 0, then 2 times 0 times whatever is going to be 0. If what's inside this bracket is 0, 2 times whatever times 0 is going to give y equals 0. Here, we only have one x value, one set of brackets. We'll look at what the squared means when we expand it in the next section. But for now, there is a case where you only have one x-intercept, so that's fine. We can do that too. So now we're going to solve. Bring the 4 to the other side, and you get positive 4. Bring the 2 to the other side, and you get negative 2. Or maybe you could have seen that x minus 4, to get 0, if it's minus 4, you need plus 4. X plus 2, to get 0, you need minus 2 to go with plus 2 to get 0. Or you can do this math every time. So same thing here. You just, simple algebra, bring it to the other side. But we're looking for the zeros. When is it going to be equal to 0? So now x is 4, y 0, x is negative 2, y 0, and 4 0. Okay, so to find the vertex, I apologize, this perhaps should have been a bigger box, so that's okay. So we're going to do two things. Over here, we wrote it as r plus s divided by 2. You can write it as the zeros divided by 2, whatever you like. You want to write the general form on this slide as well to make it emphasize more. of the negative sign in the um, general formula, then really, if you're looking for RNS, you're just looking at the sign, or like this is negative. So if it's negative here, that means this value, the R value, is actually positive. Or this value is negative. Since this is positive, the S value is actually negative. So this might make more sense to you to just write this, add the zeros and divide by 2. So we're going to do 4 plus negative 2. And it makes sense if you think about it in the graph way. If the graph is crossing at 4 and negative 2, you're looking for that halfway point. Again, this will work as well. You just have to think about what negative negative means and what negative positive means. So if you don't like that, if negatives and integers bother you, then just think of it as the zeros divide by 2, and that'll work. Okay, so now the x value is 1, okay? The only weird thing with factored form is we have 2 spots now where there's an x, okay? So you just want to make sure you plug in the x of 1 in both spots. And again, if you have a great relationship with your calculator and you can do brackets, then you can type it in just like that. You can show all your work. When you multiply, it doesn't really matter what order you do it in. So 2 times negative 3 is negative 6 times 3, negative 18. So usually when you have a weird vertex like this, then you probably aren't given the graph because it would be like a huge grid, right? Compared to like a 10 by 10, which is normally what we have. So here we only have 1. That makes our life easier. So x is 2. So now that we have our vertex, so that's what this is, the x value. I don't want to squish it anymore. So that's on the other side, okay? So we just write x equals 1, x equals 2. So now this is where standard form would have been more useful. However, if we have a y-intercept, which this parabola doesn't, but let's change it. The y-intercept, what's the x value? Yeah. So as long as wherever there's an x, we put a 0, we can find y. So 2 times negative 4 is negative 8 times 2, negative. So again, negative 64, that's an ugly y-intercept. So direction of opening. So what I'll do, I'll highlight so I don't have to squish. Okay, so you look here and here. This one is positive, so how does it open? Up. This one's down. So even when you have to do max or min, even do a quick sketch like if it opens up, right, then that's the lowest or minimum. If it opens down, that's the highest or max. Because you have a 50-50 chance, right? It's either one or the other. And then this is the y value of vertex. Okay? And then similarly, you could also be given a parabola. I apologize because yours, the grid lines are not very dark on there, but you can see. So what are the zeros? Oh, I see. They're 1 and negative 2. Doesn't matter which one you write first. For the vertex, you can see on my picture where the vertex is. On yours it sucks, so just solve for it. Add the zeros, divide by 2. So this graph, actually each of the 2 spots is 1, so you can clearly see on mine, sorry about yours, that it's negative a half, okay? Y is tough because we don't have an equation here. So this, it actually comes out to It's 11.25, but you can, like, really hard to tell on your graph, so like above 11. I'm going to put, because you can't figure it out, I'm going to put negative 11, okay? And then I'm going to put a point. I mean positive 11, sorry. If fractions bother you, you want to change it to negative 0.5. You can do that too. That's fine. What's the y-intercept? Yeah, 10 or 0, 10. It opens down, which means it has a maximum, and the approximate value is 11. Okay? So what we'll do, the break for grade 10 is 105. So you can work now until 105 on this, and then at 110 sharp, I want to start 3.4. So 3.4 is really, not that these aren't important, but 3.4 is going to be an important math skill for the forever, okay? So we're going to do something called FOIL, or expanding binomials. So 110 come when, like, just at 105 you can go for your break, and then 110 we're going to do 3.4. Yes.